In this video, we'll see how to solve examples on bending stress or flexural formula in case of cutout section. The allowable bending stress is 50 MPa. We have to find out what will be the uniformly distributed load the beam can carry if it is a simply supported beam having a span length of 4 meter, and this real W Newton per meter that we have to find out. Now, the cross section of the beam is shown in the figure. First step is always to calculate the centroid of this. So we'll calculate y bar. For that, we have taken OA as the reference. So we are having the cutout section. So this is the rectangle of dimension 75 plus 75, that is 150 plus 90, that is 240 by 90. 45 plus 45, that is 90. So 90 is the width and 240 is the depth of this section. And two holes are drilled over here, or they are cut out from this section. 1 and 2 are the two holes of 50 diameter. Now, taking OA as the reference, we'll calculate the values of y1, y2 and y3 first, and then we'll start with the calculation. So as you can see, this is y1, that is nothing but 75 Then you can say that y2 is nothing but 75 plus 90, that is 165. And this y3 is nothing but 75 plus half of 90, that is 45. So 75 plus 45, that is nothing but the value of y. Now we have seen the values of y1, y2 and y3. y1 is nothing but 75 y2 is 165 and y3 is 120 Area A1 and A2, they are of the circular cross section, because 50 diameter holes are removed from this rectangular plate. So it is pi by 4 d square. Diameter is 50 So it is pi by 4 50 square, that is 1963.45 square. A1 and A2 are same. Then A3 is the area of the rectangle, that is width is 90 and depth is 240 So it is 90 into 240. Now from this third section, that is rectangular section, we have drilled two holes over here. So we have taken out these circular holes from this. So while calculating y bar, you have to subtract 1 and 2 from 3. So it is A3V3 minus A1Y1 minus A2Y2 divided by A3 minus A1 minus A2. So substitute the values. A3 is this particular value, Y3 is 120, A1 is 1963.45, Y1 is 75, and so on. So that you will get value of Y bar is equal to 120 Now next step is always to calculate the radius of gyration for the given particular section. So let us calculate radius of gyration K1, K2, K3. So we have to take the mod value or positive value, and therefore we have just written K1 is equal to Y bar minus Y1, that is 120 minus 75, that is 45 Then K2 is equal to Y bar minus Y2, that is 120 minus 165 So it is also, we have to take into consideration the positive value. So this is also 45 and then K3 will be equal to Y bar minus Y3. So Y bar is 120 and Y3 is also 120. So that value will be equal to 0. So it is 120 minus 120. So again, Ixx will be 3, Ixx3 minus Ixx1 minus Ixx2. Ixx3 is that of the third section, is the rectangle, that is 1 by 12 BDQ plus AK square. Ixx1 and Ixx2 is that for this circular holes 1 and 2. So it is pi by 64 d raised to 4 plus AK square. So these are the values of moment of inertia for rectangular section and for circular section. From the rectangular section, we have cut out the circular holes or circular section. Now substitute the value of width and depth. Width is 90 for rectangle and depth is 240. Area A3 already we have calculated, so that also you can substitute, but K3 is 0, so this total term will be 0. Now diameter is 50, so pi by 64, 50 raised to 4. Area is 1963.45. Then K1 is 45 and square of that. Similarly, here also the same terms will be there. because area is same and K is also same. So we have substituted those values, A2, K2, those values are substituted, and value of diameter is also substituted. So value of Ixx comes out to be 95.11 into 10 raised to 6 mm raised to 4. Now distance of neutral axis from extreme fiber. So either you can say that this is the extreme fiber or this top fiber is the extreme fiber. From x-axis axis, the distance is this particular distance, that is overall depth divided by 2. That is overall depth is 240. 90 plus 75 plus 75 is 240. So this bottom layer from x-axis axis is at a distance of 120 mm. So this distance is 120 mm. Now using these values, we can calculate the value of zxx, that is section modulus, that is I upon y. Substitute both these values. So value of zxx comes out to be 792.58 into 10 raised to 3 mm cube. Now we have to find out the value of maximum bending moment. Now in case of simply supported beam carrying uniformly distributed load, it is WL square by 8. Now here the units are very important. So just substitute the value. W we have to calculate. Length is 4. So it is 4 square divided by 8. So it is 2W. Now what will be the unit for this? W is in Newton per meter and length is in meter square. So meter and meter square, it will be Newton meter. So this unit 16 divided by 8, that is 2W Newton meter. Multiply it by 1000 so that it will be in Newton mm. So it is 2000 small w Newton mm. Now using the bending stress formula, bending stress is equal to m upon z. So substitute these values now. So m will be equal to sigma b into z. Permissible bending stress is given as the value is 50. Zxx we have calculated, and this is moment is 2000 w. So doing this calculation, you will get the value of w, that is nothing but the uniformly distributed load, as 19814.5 Newton per meter. So in this way, we can solve examples on bending stress. Thank you very much for watching.